There's a guy at every boat ramp who'll tell you running at full throttle will blow your engine. There's another guy 3 slips over who runs wide open every single weekend and swears his engine has never been healthier. So who's right? Turns out they're both wrong. And the truth is way more interesting than either story, because what actually happens at full throttle has almost nothing to do with the throttle itself. Today, we're pulling back the curtain on what's really going on inside your outboard when you pin it, why some engines love maximum RPM while others explode, and the one mistake that kills more engines at full throttle than anything else. Stick around, because this is going to change how you think about your engine forever. What full throttle actually means. Let's start with the basics, because most people get this completely wrong. When you push the throttle all the way forward, you're not forcing the engine into some dangerous red zone. You're asking it to operate at its maximum designed RPM range. That's a huge difference. Every outboard manufacturer publishes something called a watt operating range. Watt means wide open throttle. For most modern 4-stroke outboards, that range is somewhere between 5,000 and 6,000 RPM. Some are lower, some are higher, but they all have a specific range printed right in the owner's manual. Here's what matters. That range isn't a danger zone, it's the design target. The engineers who built your engine calculated every component to handle those RPMs safely. The pistons, the connecting rods, the crankshaft, the valves, everything was designed knowing the engine would spend time at maximum RPM. So when your engine reaches that range with the correct propeller installed, 3 things are happening exactly as planned. First, internal loads are within the tolerances the engineers calculated. Second, cooling systems are flowing the exact amount of water they were designed to flow. Third, lubrication is delivering oil where it needs to go at the pressure and volume it was designed for. But here's where it gets really interesting. If your engine doesn't reach that RPM range at full throttle, problems begin immediately. And I'm not talking about small problems. I'm talking about the kind of stress that destroys engines in ways most people never see coming. Think of it like riding a bicycle. If you're in too high a gear and you're pedaling as hard as you can but barely moving, you're working way harder than if you were in the right gear spinning at a comfortable cadence. Your engine is the same way. If something is preventing it from reaching its designed RPM range, it's working harder than it should to produce less power than it's capable of. That imbalance creates heat, stress, and wear the engineers never intended. The throttle position doesn't matter nearly as much as whether the engine can reach its proper RPM. Get that in your head first, because everything else builds on that foundation. What's really happening inside? At full throttle, dramatic changes happen inside your engine, and understanding them is crucial. Fuel flow increases massively. We're talking about going from maybe half a gallon per hour at idle to 10 or 15 gallons per hour at WOT on mid-size and larger outboards. Cylinder pressures rise as more fuel and air gets squeezed and ignited. Exhaust gas temperatures peak because you're burning more fuel more often. And your cooling system is working at absolute maximum capacity, trying to keep everything from melting. Modern outboards are designed to handle this, but here's the catch. Briefly or intermittently, not continuously for hours. Unless you bought a commercial rated engine specifically built for sustained high-load operation, your recreational outboard assumes you'll use full throttle in short bursts, not marathon sessions. Now here's the most important thing I'm going to tell you in this entire video. High RPM doesn't kill engines, heat and detonation do. Let me say that again because people get this backwards constantly. The RPM number itself isn't dangerous. What's dangerous is heat buildup and abnormal combustion, and those happen when other things are wrong. Engines running lean, meaning too much air and not enough fuel, suffer massive combustion temperature spikes. The mixture ignites too early or burns too violently, creating shock waves inside the cylinder. That's called detonation, and it destroys pistons, rings, and cylinder walls faster than almost anything else. This shows up at full throttle because that's when fuel demands are highest and any mixture problem gets amplified instantly. Similarly, an overpropped engine, which we'll get to in detail because it's huge, can't reach its designed RPM at full throttle. It's working under enormous load at lower speeds where cooling and oil flow aren't optimized for that power level. Cylinder pressures stay high for longer than they should. Heat builds up because the engine isn't spinning fast enough to move cooling water and air through its systems efficiently. The engine literally cooks itself, not because you push the throttle forward, but because something else in the system is forcing it to work outside the envelope the engineers designed. The cooling system truth. Here's something that surprises almost everyone. At higher speeds and RPM, your cooling system actually works better, not worse. Water pickup pressure increases as you go faster. The impeller spins faster and outputs more flow. Cooling water movement through the engine often improves dramatically at full throttle compared to idle or slow speeds. So why do some engines overheat at WOT? Because they already have cooling system problems that full throttle exposes. When an engine overheats at WOT, don't blame the throttle. Investigate the cooling system because something failed there, probably long before you ever noticed. If this is already changing how you think about full throttle, hit that subscribe button so you don't miss what's coming next. Because we're about to talk about the #1 engine killer at full throttle, and I guarantee most of you have never even thought about it. The propeller problem that kills engines. Here it is. The single biggest killer at full throttle. The thing that causes more engine failures than anything else we've talked about combined. Incorrect propeller selection. Most boaters have no idea their prop is wrong. They run the prop that came with the boat, or they picked one based on what their buddy recommended, or they chose it because it was on sale. And that wrong propeller is slowly destroying their engine every time they use full throttle. Let me explain how this works, because once you understand it, you'll never think about props the same way again. Your engine has a rated WOT RPM range. Let's say it's 5,500 to 6,000 RPM. The correct propeller allows your engine to reach somewhere in that range at full throttle with your typical load. Not below it, not above it. Right in the sweet spot. An overpropped engine has too much pitch. The blades are angled too aggressively. It's like trying to ride a bicycle in too high a gear. You can pedal as hard as you want, but you can't spin the pedals fast enough to go fast. An overpropped outboard at full throttle can't reach its rated RPM. Maybe it only gets to 4,800 or 5,200 RPM when it should be hitting 5,800. What's happening inside that engine is brutal. It's working under massive load at lower RPM than it was designed for. Cylinder pressures are incredibly high because the engine is straining against resistance. Heat builds up because the engine isn't spinning fast enough to move cooling water efficiently. Oil flow is lower than it should be for the load level. Combustion is less efficient because the engine is lugging. This is why overpropped engines die. Not from full throttle, but from being forced to work outside their design parameters while at full throttle. The engine is basically in the wrong gear, fighting to move a load it shouldn't have to fight, and cooking itself in the process. Underpropped engines have the opposite problem, but also create damage. Too little pitch means the engine revs too easily. At full throttle, it might scream up to 6,500 or 6,800 RPM when it should stop at 6,000. In extreme over-rev situations, especially on older or modified engines, this can risk valve float, where the valves physically can't close fast enough at excessive RPM and you lose compression. Even if that doesn't happen, you're increasing wear on every moving component because they're moving faster than the engineers intended without producing proportional power. It's like revving your car engine in neutral. Lots of noise, lots of motion, but inefficient and damaging over time. Manufacturers are unanimous on this. The correct propeller is the one that allows your engine to reach its rated WOT RPM range with your typical load. That's it. That's the only correct answer. If you're not in that range, your prop is wrong, and running at full throttle will eventually cause problems regardless of how well you maintain everything else. Get the prop right, and full throttle becomes safe and even beneficial. Get it wrong and you're slowly destroying your engine whether you realize it or not. How modern engines protect themselves. If you're running a modern outboard, probably anything built after 2005 or so, your engine has electronic safeguards actively protecting it at full throttle. Sensors monitoring temperature and combustion behavior, and on some engines, dedicated knock sensors listening for detonation. Temperature sensors monitoring cylinder head heat. RPM limiters prevent mechanical overspeed, and sophisticated engine computers that can reduce power instantly when something goes wrong. When you're at full throttle and something starts to fail, here's what happens. The computer detects abnormal knock or excessive temperature. Within milliseconds, it retards ignition timing to prevent detonation. It reduces fuel delivery to lower cylinder pressures and temperatures. It caps RPM automatically to prevent mechanical damage. Some engines will even force themselves into limp home mode, limiting power to maybe 2000 RPM to get you back to shore safely. If your modern engine survives watt abuse, it's often because the computer stepped in and saved it without you even knowing. You feel the engine lose power, maybe hear an alarm if you're paying attention, and you back off thinking everything is fine. Meanwhile, the engine management system just prevented what would have been a catastrophic failure 10 seconds later. Older engines didn't have any of this. Pre-2000 outboards had maybe a basic over-temperature alarm and mechanical governors at best. Nothing monitoring combustion quality in real time. Nothing actively adjusting timing and fuel to prevent damage. Those engines relied entirely on proper setup, correct propeller selection, and operator awareness. When things went wrong at full throttle on older engines, they failed immediately and expensively. Holes in pistons, seized bearings, cracked cylinder heads. The kind of damage that totals an engine in seconds. Modern electronic protection is incredible, but it's not magic. It can compensate for minor issues and buy you time to address problems. But it can't save an engine from major failures like a completely blocked cooling system or catastrophically wrong propeller pitch. The computer prevents immediate destruction, but it doesn't fix underlying problems. You still have to do that part. Why commercial engines are different. Commercial rated outboards handle full throttle better than recreational engines, and understanding why teaches you a lot about engine design. Commercial engines are essentially detuned versions of recreational models. They use the same basic architecture, same displacement, but with critical differences. Heavier internal components, pistons and connecting rods built thicker and stronger. More conservative RPM limits, even though the engine is physically capable of higher revs, cooling systems sized more generously, more. Simpler electronics with fewer potential failure points. All of this prioritizes longevity and abuse tolerance over peak power and weight savings. A commercial 150 horsepower engine might use the same block as a recreational 175, but with different internals and tuning that make it bulletproof for sustained hard use. Recreational engines assume you'll use variable throttle most of the time, cruise below max RPM normally, and only hit watty in short bursts for repositioning or getting on plane. Commercial engines assume you'll run them hard continuously in conditions recreational boaters would consider abusive. That design assumption changes everything about how the engine is built and what it can tolerate. This doesn't mean recreational engines can't handle full throttle. They absolutely can, when used as designed. It means they're optimized for different usage patterns. Your recreational engine at full throttle for 10 minutes running between fishing spots is perfectly fine. The same engine at full throttle for 3 hours straight pushing a heavy commercial load is outside its design envelope and will fail prematurely. Know what your engine was built for. Use it accordingly. Commercial operators who choose recreational engines to save money learn this distinction the expensive way when they're replacing power heads at 1,500 hours instead of 5,000. The truth about carbon buildup. Some boaters never use full throttle because they're afraid of damaging the engine. Ironically, never using full throttle can actually cause problems they're trying to avoid. Let me explain how this works. At low RPM operation, combustion temperatures are lower. Carbon deposits form naturally during combustion, tiny particles of partially burned fuel that accumulate on valves, piston tops, and combustion chamber walls. At high temperatures, these deposits burn off. At low temperatures, they stick around and build up over time. If you only run your engine at displacement speeds, trolling and idling most of the time, those carbon deposits accumulate constantly without ever burning off. Eventually they cause rough idling, reduced performance, increased fuel consumption, and hard starting. In severe cases, carbon buildup can cause pre-ignition, where deposits glow hot enough to ignite the next fuel charge before the spark plug fires, creating damaging pressure spikes. Running at full throttle occasionally burns off these deposits. Combustion temperatures get high enough to oxidize the carbon, turning it into gas that exits through the exhaust. It's essentially a self-cleaning cycle that the engine performs when operated at its design parameters. You don't need hours of watt to achieve this. Even several minutes of sustained high RPM operation can help burn off accumulated deposits when done periodically. Think of it as preventive maintenance rather than risky behavior. Never using full throttle also masks other problems. Carbon buildup goes unnoticed until it causes obvious symptoms. Incorrect propeller pitch remains hidden because you never demand enough power to realize the engine is under revving. Cooling system restrictions develop gradually, only becoming obvious when you finally need full power and discover the engine overheats. The engine doesn't fear what? It fears incorrect setup, poor maintenance, and operation patterns that prevent it from cleaning itself and operating across its full design range. What actually causes the damage? Let's get really clear on what causes damage at full throttle, because it's almost never the throttle itself. The real culprits are overpropping, which we've covered extensively because it's so important. Poor fuel quality, especially ethanol contaminated or old gasoline that doesn't combust cleanly. Lean fuel conditions where the mixture has too much air and not enough fuel. Spiking combustion temperatures. Restricted cooling from blocked intakes. Damaged impellers, or corroded passages. Ignoring warning signs like unusual sounds, temperature alarms, or performance loss. And running beyond recommended RPM ranges with the wrong propeller. Notice what's not on that list: throttle position. The throttle is just asking the engine to produce power. Whether producing that power is safe depends entirely on whether everything else in the system is set up correctly. An engine with the correct propeller, clean fuel, proper fuel mixture, functional cooling system, adequate lubrication, and regular maintenance can run at full throttle safely whenever conditions permit. An engine with any of those factors wrong will suffer damage even at partial throttle settings, though the damage develops more slowly and might take months or years to become obvious. Full throttle is a stress test. It reveals weaknesses in your setup, your maintenance, and your components. The throttle doesn't create problems, it exposes them. And honestly, that's valuable because discovering a cooling system restriction at the dock is infinitely better than discovering it 30 miles offshore in rough conditions. Think of full throttle operation like a medical stress test. Doctors put you on a treadmill and make you run because exercise reveals heart problems that don't show up when you're sitting still. Running on the treadmill doesn't cause heart disease. It exposes existing conditions that might otherwise go undiagnosed until they cause a heart attack. Your outboard works exactly the same way. WOTI operation shows you where the weaknesses are so you can address them before they cause catastrophic failure at the worst possible moment. So, what's the real answer? Running an outboard at full throttle is completely safe if your engine is properly set up, maintained correctly, and configured with the right propeller. It's dangerous if your engine is fighting itself because of wrong propeller pitch, restricted cooling, poor fuel quality, inadequate lubrication, or worn components. WOT doesn't break engines, it exposes them. The boaters who destroy engines at full throttle almost universally have underlying problems they ignored. Wrong prop that forced the engine to lug. Dirty or damaged impeller restricting cooling, old contaminated fuel causing detonation, worn piston rings losing compression, low oil level starving bearings. These issues cause damage at any throttle setting, but full throttle accelerates the timeline from months of gradual degradation to minutes of catastrophic failure. The boaters whose engines run forever, accumulating thousands of hours without major issues, often use full throttle regularly. Not because full throttle is magic, but because they maintain their equipment properly and understand what their engine needs to operate safely across its full power range. They check WOT RPM against manufacturer specifications and adjust prop pitch if needed. They inspect and replace impellers annually. They use quality fuel and add stabilizer if the boat sits. They change oil on schedule with the correct viscosity. They pay attention to warning signs and address small problems before they become catastrophic. Your engine was designed to operate at full throttle. That's not marketing hype or macho posturing, it's engineering fact. The question isn't whether full throttle is safe. The question is whether you've maintained and configured your engine to do what it was designed to do. Get the propeller right so the engine reaches its rated RPM. Keep the cooling system clean and functional. Use quality fuel and fresh oil. Pay attention when something sounds or feels wrong. Do those things, and full throttle becomes just another operating condition, no more dangerous than cruising at 3,500 RPM. Get those things wrong, and even babying your engine at partial throttle will eventually cause problems. The throttle isn't the issue, the system behind it is. So here's what I want you to do right now. Go check your owner's manual and find your engine's watt RPM range. Next time you're out on the water in safe conditions, run at full throttle for 30 seconds and watch your tachometer. If you're in the range, your prop is probably correct. If you're significantly below or above the range, you need a different prop before you cause damage you can't see yet. And if you found this useful, if this changed how you think about your engine, I want you to hit subscribe so you don't miss out on the next upload. Drop a comment and tell me, are you a full throttle every trip person or a never go past 3/4 person? And more importantly, do you know your watt RPM range? Let's talk about it.